The concept covered in this question is replacing part of a mixture, which essentially means that we take out a portion of the mixture and replace it with one of the components in the mixture. Let's read the question and solve it systematically initially, and then let's also have a formula through which we can solve it quickly. I would recommend the formula method for solving it in the examination so that you can save a lot of time. A 100-liter mixture of milk and water contains 36 liters of milk. X liters of this mixture is removed and replaced with an equal quantum of water. We are removing the mixture and replacing it with water. If the process is repeated once, we did it once, we are repeating it once, so the process is done twice. The concentration of milk stands reduced at 25%. What we need to find out is what is X, how much was removed each time. This is a 100-liter mixture. It contains 36 liters milk. That's what they mentioned. So the balance 64 liters has to be water in it. We are removing X liters out of this 100. If you remove 10 liters out of 100, you are removing 10%. If you are removing X liters out of 100, you are removing X percentage of the mixture each time. If you are removing X percentage of the mixture, then obviously you are going to be removing X percentage of whatever the mixture comprises. What does the mixture comprise? The mixture comprises milk and water. So each time when we are removing X%, we will be removing X% of the milk available at that point in time and X% of the water available at that point in time. So when I remove X% of the mixture, X percentage of milk is removed, X percentage of water is removed. What gets added back is X liters of water. So keep that in mind. So if I'm removing X percentage expressed as a fraction is going to be X by 100. For sake of convenience, let's just say this X by 100 is equal to Y. So that we won't be writing X by 100 each time. We'll just write it as 100. Finally, when we find the value of Y, we will substitute it as X by 100 and find the value for X because we need to find the value for X. Instead of carrying a fraction, I'm carrying one single variable which is Y. So every time we'll have to write X%, I'm going to replace it with Y. Let's look at what happens. Initially, the quantum of milk is 36. At the end of the first iteration, after having removed X percentage of the milk, how much milk is getting removed? X% of the milk is getting removed. So X by 100 of how much milk is there? 36 is there. We said we'll replace this X by 100 with a single letter Y. So how much of milk is going to be removed? We're going to remove 36Y of milk the first time. Because we had 36 liters of milk and we are removing X% of the mixture, X percentage of 36 should be removed, which is X by 100 of 36 should be removed. We are replacing that X by 100 with the assigned value that we are given, which is equal to Y. So at the end of the first iteration, how much milk will be left? We started with 36 liters of milk. We removed 36Y. So the amount of milk that will be remaining will be 36 minus 36Y. I'll simplify and write it as 36 into 1 minus Y. At the end of the first iteration of removing X percentage or X liters of the mixture and replacing it with X liters of water, how much milk will be left? We'll be left with 36 into 1 minus Y milk. Now, the second process, we're repeating it again. What is going to happen? We're going to be removing some more milk out of it. How much milk will be removed? However much milk is there, Y of that is going to be removed. So what we are going to remove the second time is 36 into 1 minus Y. That's what was remaining at the end of first iteration. We are removing Y of that. So how much will be left? 36 into 1 minus Y minus whatever was removed, which is 36 into 1 minus Y into Y. So if we take this 36 into 1 minus Y common outside, so what is going to be left is going to be 36 into 1 minus Y into 1 minus Y. We'll quickly infer one important thing at this point. We'll realize that at the end of each iteration, we'll be left with 1 minus Y of what we started with. So if we repeat this process twice, we'll be left with 36 into 1 minus Y the whole square. If we do this process 4 times, we'll be left with 36 into 1 minus Y raised to the power of 4. So this is the amount of milk remaining at the end of 2 iterations. The question mentions that the amount of milk remaining is 25%. 25% of what? Of 100 liters. So the amount of milk remaining is equal to 25. We have one equation, one variable. Let's solve this. 1 minus Y the whole square is equal to 25 by 36. I brought this 36 down to the denominator. Let's take square root on both sides. So 1 minus y is equal to 5 by 6. Square root of 25 is 5. Square root of 36 is 6. So y is equal to 1 minus 5 by 6, which is equal to 1 by 6. I'll just go back one slide and let's see what is given. This y is nothing but x by 100. We found the value of y to be equal to 1 by 6. So let's say this is equal to x by 100 because y is equal to x by 100. What do we have to find out? We need to compute the value of x. So cross multiply and get the answer. X is equal to 100 by 6, which is nothing but 16.66 liters. So each time we have removed 16.66 liters of milk away from of the mixture away from it. Quickly put this in a printed form so that we can capture it again. 1 minus y the whole square is equal to 25 by 36, bringing it down to the denominator. We have taken square root on both sides. So we get y is equal to 1 by 6. But we know y is x by 100. So we found out the value of x to be equal to 16.67. So this is going about it one step at a time, deriving actually each step of the way. I'll give you a formula to basically do this in a jiffy. This is what the formula is going to look like. Always use the item whose concentration is going down. You're replacing it with water, which means what you're letting go down is the amount of milk. So you're going to be using that every time in this formula. Percentage of milk left divided by percentage of milk originally present is equal to 1 minus x by 100 raised to the power of n. Where n is the number of times this operation is done. We did it once and we repeated it once, which means it's been done twice. So generalized formula is basically, this is going to be the generalized formula. Percentage of milk left divided by percentage of milk originally present is equal to 1 minus r by t raised to the power of n. What is r? R is the quantity removed each time. In this case, it is x. What is t? T is the total volume. In our example, the total volume ended up being 100, so we went with 100. But if it is a 40 liters, don't worry, it is 1 minus r by 40 raised to the power of n. So let's basically plug in the values to check out we are getting the same answer. 25% milk is left finally, divided by 36% milk is what we started with, is equal to 1 minus x by 100 whole square. Take square root on both sides, we'll get the same answer. X is equal to 16.67. Quickly again, take you back one slide to recall the formula. The formula is the concentration of the item, new concentration, divided by the old concentration. Whatever is left divided by the original is equal to 1 minus r by t raised to the power of n. What else can you do to prepare for the test? Good question. You can always start by subscribing to this channel and signing up for the most comprehensive and affordable GMAT Quant course that's available online at gmat.visaco.com.